Hello everyone, my name is Ahmed Bircis AYDIN. This is my Physics 102 project. Let's talk about my project. My project is that we try to observe the behavior of capacitance in terms of three variables. The aim of my experiment is to observe that how distance between plates and area of plates and dielectric constants affect the behavior of capacitance. I will try to observe whether the capacitance of capacitor depends on distance between plates, area of plates, and dielectric constant. I will use the capacitor's feature. My theory is that area of plates is directly proportional with the capacitance, and also the electric coefficients of materials are directly proportional to the capacitance. However, the distance between plates is, I have some materials for my experiments. Firstly, pairs of conductive plates which have different areas, and I have the electric materials such as foam, paper, and glass to insert between plates. And I have a ruler to measure the distance between plates and calculating the area of plates. And I have a multimeter to record the experimental capacitance, and I have a camera to record them. Okay. Çek abi, çek. 69 geliyor. 400 bir şey geliyor daha demin ya. 430.
Altına sağladım. Bunu da tepeden bıraktım falan. Yani bıraktığım yüksekliğe göre hızın geçtiğinden maksimum orta düşen montajda hani hıza bağlı şey olacak ya.
I want to talk about the process. Firstly, I adjusted two parallel pair of conductor plates at some distance, and area of plates and dielectric coefficients were constants. Distance between plates are 0.001 meter, 0.002 meter, 0.004 meter, and 0.006 meter, respectively. I calculate the capacitance of the different distance by formulas, while all the components are the same, are fixed. I measured the capacitance by a multimeter, and I repeated the same steps for a different distance as I mentioned before. And then second part of my experiment is that I try to understand how the area of plates affects the capacitance. My plates areas are 0.024 meter square, 0.025 meter square, 0.042 meter square, respectively. Then I measured the capacitance by a multimeter for different pairs of plates which have different areas from each other. However, distance from the plates and dielectric coefficients will be constant for this step. And then I calculate the capacitance of the capacitor with dielectrics for different materials by my theoretic equations, while other components will be fixed. Dielectric coefficients are 5 for glass, 1.83 for foam, 3.8 for paper, 1.00059 for air. Actually, I take 1 for air because 0.00059 is a very small number, so I decided to neglect that. The electric coefficients was inversely proportional. Okay, so change it by inserting different materials, namely glass, foam, papers, between the parallel plates, while areas of plates and distance between plates are constant. Then I measured the capacitance by multimeter for different dielectric materials. For air, I didn't put anything because there's a air for naturally. However, I want to mention that and I recorded my data. I calculated the error percentage between theoretical values and experimental values for capacitance. I built three tables which I will show you, and then I scratched the graph which also I will show you for area of plates. Actually, I want to give a short information about my graphs. I sketched graph for capacitance versus dielectric coefficient, area of plates, and 1 divided by distance. It's so important. X represent coefficient, area of plates, and 1 divided by distance between plates, and Y represent the capacitance. I take 1 divided by distance instead of just distance because it is much easier to sketch a graph for me. Then I want to make a brief error analysis. For dielectric part of my experiment, under the ideal conditions, my theoretical dielectric coefficients are 5, 1.8, 1.7, 3.7, and 1.00059 for glass, foam, paper, and air respectively. However, in this experiment, materials are not ideal. For example, materials may have some space within, such as foam. Additionally, these dielectric coefficients are calculated for certain temperatures, namely 20 degrees Celsius. But the place where the experiment was made is warmer than that. Even so, I did not consider the temperature. It could affect my measurements. Furthermore, my materials may not be homogeneous. Although I tried to fix the distance between the plates, I could not success that because of insufficiency of the ruler and limited human eye. And I have glasses. Hence, materials which are used in my experiment may not comply with these dielectric coefficients. This might be why I took different values, different than the theoretical values. The error rates of plates are for the distance part of my experiment, I may mismeasure the distance between the plates because my ruler might not be sensitive enough. Moreover, because of insufficiency of ruler, I may mismeasure area of plates. This could be why I took different values from theoretical values. For the third part of my experiment, which is area, about the area, for distance part of my experiment, I mismeasure the distance because my ruler might not be sensitive enough, and although I try to fix the distance between plates, I might have adjusted distance slightly different from each other unintentionally because of, again, limited human eye and insufficiency of ruler. Moreover, because of insufficiency of ruler, again, I may mismeasure the area of plates. This could be why I took different values from the theoretical values. Additionally, capacitance of the capacitor observed were slightly different than theoretical capacitance in each attempt. I had several error percentages for different independent variables at 3 parts of experiment. These error rates commonly may have been caused by the overusage of multimeter and non-ideal conductivity of these plates. In conclusion, I performed this experiment to understand how dielectric coefficients distance between plates and area of plates affect the capacitance of capacitor. I expect that the area and dielectric coefficients are proportional with the capacitance, while the distance between plates and capacitance are inversely proportional because of theoric formulas. Actually, I will show my theoric formulas. Moreover, I can end up with that area and dielectric coefficients proportional with the capacitance, while distance between plates and capacitance are inversely proportional. Although I have some error percentage, these results of my experiment comply with the relationship between capacitance and independent variables, which my formulas predict. There were some inconsistency in my experiment. However, I obtained not really large amount of error rates. If I had not had a difficulty while observing capacitance with a multimeter because I used my hand to fix my plates, for example, I would have only some problems which are non-ideal conductivity of plates and non-ideal non-conductivity of non-ideal non-conductivity and limited human eye. And they would not have a big impact on my capacitance, as it not likely to change persistency in a place. And if I used brand new materials on my experiment, then I could acquire more accurate data. Thus, I would obtain more accurate values of my experiment. Experimental capacitance I would obtain more accurate values of experimental capacitance with respect to the theoretical one. Thanks for your listening. And I will show my formulas.